Basically, what we're going to be talking about today a little bit, it's about digital prototyping, what that is, and how can Fusion work along with you, basically to test your designs to make sure that the stuff that you're creating is actually a little right, that you're not going to get in trouble in not only with the performance of your product, but also with manufacturing of the product as well. Okay, as you will see, Fusion is a great tool for doing this type of work, right? And when we're talking about digital prototyping, basically we're talking about testing our design. The prototype always refers to the creation of a version of your product. It might not be the latest version, right? It's a version that's meant to represent how the finished product will work in real life. Okay, so the usual workflow that you have in our regular industry would be think a product out, create a concept, create your prototype in real life, right? Create or design an experiment to check on the performance of the product. For example, let's suppose what we need to do is we need to design a bracket. This is supposed to be a holder for a tablet. And in this case, what it needs to withstand is the force of the weight of the tablet, right? This is supposed to use this head right here as a support, as a backing for the tablet, right? And on this portion of the model right here, or the bracket, it's supposed to be screwed to another component, to a table or whatever it needs to be supported, right? So if we were talking about, I don't know, 10 years ago, 15 years ago, we would think about creating an actual physical prototype, running some tests, spending money on creating those prototypes just to see if this is going to work, right? But with today's technology, we can create a digital version of that, right? We can create a simulation and we can test if the component it's gonna withstand that force as if it were working on real life, right? But the job doesn't end there, right? You gotta think about how you're gonna uh, manufacture the actual model, right? Everything's not just like a straight line. It's not like you're testing the prototype, either it passes or maybe you do a couple changes and that's it. As you might know, when you send that to manufacturing, you find out, okay, this is not supposed to be manufactured this way. I cannot pass my tool through this hole, or maybe now milling isn't the best way to go here. Those kind of things. Okay, so the design process is always an iterative process, right? You gotta think about, or you find out stuff, or uh, let's call it variables that you haven't taught before, right? So you gotta create new prototypes. You gotta test them out again, over and over and over again. And even in the digital world, that involves a lot of work. Okay, so in real life, that would mean actually manufacturing the prototype, breaking it, testing it, going back to your CAD, making changes, manufacturing it again over and over again. In the digital world, it would imply creating the model, sending to FEA or to simulation, right? Finding out that the forces aren't, or that the force is too much, or that the section that you're testing is too thin, or something like that, and going back to the CAD model, right? And jumping backwards and forwards between your simulation tool, for example, I don't know, Master or Ansys or whatever, right? And your CAD tool. So it involves a lot of steps, even if you're talking about a digital prototype, right? And that's when Fusion comes in. The beauty of it is that everything is integrated in one single tool. Okay, so there's no need for you to jump from your CAD design exporting the model, sending that to your FEA, then send that to your manufacturing guy, you name it, okay? Everything is integrated in Fusion. You get design, you get the simulation tool, you get the manufacturing tool to simulate how I would manufacture that in real life, right? And you get documentation as well, okay? All of that, it's part of the workflow on Fusion. So that's what we're gonna do today. We're gonna take a look at models such like this one, right? Well, we're gonna show how we can set up the simulation and how that's integrated into the manufacturing as well, even if we make changes to it, okay? So we're gonna start with this. This is a little model that I created for this webinar. I'm gonna go in here. On this one, I'm basically just defining a couple components. I have everything integrated in one single sign, right? Tap support, close this one. I got the components, the head, I got base, right? And whoops, I'm gonna place it like this. There we go. I'm gonna show what this is supposed to do, right? So I got my assembly, I got my constraints in here, but in this case, what I need to simulate is just the base, right? So I can access all of the workflow tools right here on the left. I'm gonna send that to simulation, right? So I'm gonna create a new simulation for this one. New simulation study, static stress. There we go, right? And just so we're aware of what's being done here in terms of the simplification of the model, it's this. I got my base, I got my head. I'm not gonna need my head, right? So I'm gonna go ahead and remove it, right? And I'm gonna get rid of all the geometry that I don't need for my model. In this case, I wanna focus. I'm thinking that this is gonna be the part where I'm gonna get most in trouble, right? So I'm gonna simplify my base part by deleting the whole. There we go. Okay. Go back here. So I already had it. Okay. And with Fusion, it's very, very simple to apply my constraints, to apply my materials. I'm just going to check that my material is set to ABS plastic. If I want to run different scenarios on materials or loads, I can do that as well. But we're going to keep it simple just to showcase the workflow, right? I'm going to specify a constraint here for my face. I deliberately created a split in this face, right? Because I'm assuming that the wall that I'm going to place this bracket in ends right here. So this is going to be the end location of it, and that's where my part is going to bend. Right? I'm going to establish a load. I'm going to place it right here. This should be around 20 newtons for approximately 2 kilograms or pounds, just to make sure that it can withstand even pushing the tablet, something like that. Okay. Now all we gotta do is define the mesh. Mesh B, gonna compute the mesh. It's a bit coarse, but can make it work, I guess. Just gonna check that the design is ready for simulation, and I can go ahead and solve my design. Right? It would take a little while, so I'm just gonna wait for a little bit. And this is all right. Close this one. Oops. static stress, and there we go. Pretty quick, right? This is the starting I'm looking at. I'm looking at this one right here. Depending on the complexity of the model, it might take some more or less time, of course. In this case, this is a static study with the mesh. Of course, we would need to make what if you're familiar with simulation terminology, we would need to make mesh independence study. That is refining the mesh around the areas where you have more stress. Make some checks, some validations as well, right? But eventually you would get the results that you want. Okay, I'm gonna jump to results that I get for my model right here. Okay, just because this is taking some time. And in this case, what I can find here is that as expected, what we get right here is a high stress area. Okay, this is probably not a good solution. I'm getting a lot of bending here. If I take a look at my safety factor, for example, I will find a safety factor of 2.121, right? And that means the component is not going to break in theory, right? But the safety factor, it's a little too small, right? You can even get suggestions for fusion. The fusion is going to tell you that the safety factor apparently means that the part is going to withstand that force, but you want to have something above 3, just to make sure that you can withstand unexpected forces, those kind of things, okay? So probably would be a good idea to make some modifications on this part, okay? So that's the beauty of it. In Fusion, we don't need to resend the model, export the model again. We can work inside of the same environment and make any necessary changes, right? Real quick here, gonna cancel this one. There we go. Gonna finish my results, and while at it, I'm gonna delete this one. There we go. And I'm gonna go back to my design and make any necessary changes. Okay. So my idea here is I'm gonna add a rigidizer over here. Okay. So I'm gonna back up a little bit in my design, right? I'm gonna go to my base and make any necessary changes. Project here, here and there. There we go. And well, my division should be here, so somewhere around here might be good. Probably header solution B, something like this. 45, yeah, that sounds about right. And I'm gonna give it an angle of 45. That's a little too much material there, right? I'm gonna change this to 60. There we go. There we go. Get my part there. Mirror my feature. This one right here. I'm gonna create the. This is symmetric around the origin, so I'm gonna search my origin here. X, Y, X, C. There we go. Right, And this is the part that I'm gonna simulate right now. Okay. Probably if we think about what the part needs for actually working, would involve creating, I don't know, like a recess here, an extrusion for placing the screw or something like that. But we're gonna keep it simple. We're just gonna make a change so we can check on the workflow. All right, so this is gonna be my new part. I'm gonna activate my support right now. I gotta define my face again, and there we go. That's my new design. Okay, and because all of it's part of the same environment, I can just go into my simulation and everything's gonna be in place already. Okay, I don't need to create a new study. I don't need to set the loads, set the constraints again. All I gotta do is update what's geometry related, specifically the mesh. All right, and now all I gotta do is solve my model, right? In this case, this is gonna take a little while, so I'm gonna open another version of this part that already has those already has the information on the simulation, right? So I can check on those results. And there we go. This is my new part with my simulation results. I can check the safety factor. I can check the stress for this new one. Of course, the stress is still gonna be at that point, right? But the stress is a lot less, almost half of it. We check on the safety factor with this model, you get safety factor of 3.3. Okay, so basically you're good. Okay, you're over 3 for general design. This is a better design. Okay, so when we're talking about digital prototyping, this is where people think the whole shebang goes. Okay, basically send your model to our simulator and checking on the stress on the model, and that's it. Okay, but if you're working on an actual industrial environment, you gotta know that this is not enough. Okay, basically because you gotta make sure that everything you're simulating not only withstands the forces that virtually you can apply to the model, but you can actually manufacture this. Okay, and you gotta create a prototype, at least jumping from the original design, right? That is the one without the. Let's press this one. Press features. There we go. The one without the plate, right? So you know this is not going to work. You know this is going to have a better chance of working in real life, right? But you got to test it out. Okay, that process in FEA in simulation is called validation, right? And Fusion can help you with that. Not only by specifying how you want to manufacture this, but how you can actually create the actual physical prototype to test it out. Okay, so you can go into your manufacturing environment. Okay, I'm gonna do this with the other one that I got right here. Right? And in this case, this is supposed to be an ABS bracket. So what I'm gonna do is I'm gonna use the most useful prototyping machine of all time for now. Greatest invention of the latest years, the 3D printing machine. Okay. So on Fusion, I can set my manufacturing for 3D printing. Okay. So I'm gonna send this to the manufacturing environment. I'm gonna create a setup from scratch. New setup. This is gonna be an additive type of manufacturing. On Fusion, you get milling, you get turning, you get cutting, you get additive. Okay, so any way you want to manufacture this part, you get on Fusion, right? I'm gonna select the machine here. Now I myself have and then the Free Pro 3D printer at home, which is basically the one that I used for printing this one, by the way. And I'm going to check on the settings for this one. This is supposed to be ABS. Manufacturing model, supposed to be this one. I'm going to manufacturing mode. Oops. Yes. There we go. I'm going to make an arrangement. All I'm going to do is set up my parts here on Fusion for 3D printing. With a little experience, you might know that on 3D printing, probably this would be the best way of orienting your model, right? But you get many tools in Fusion for making those sorts of decisions. See, if you want to minimize the build height, for example, that's going to be the less time that you can get for your 3D printing, right? Probably less time would be placing this in a horizontal way, right? But that will involve creating the platform that it's the material that's going to support the upper lid right here for my part, okay? So that's going to be more material. Those are the kinds of decisions that you can get with 3D printing in Fusion, okay? In this case, I don't care a lot about time, so I care more about material. I'm going to place it like this. I'm going to set this on my platform, right? And I'm going to generate my path, right? So creating the manufacturing data for your model is also part of the simulation, okay? And that means you can simulate how your manufacturing is going to go, how much time this is going to get, so you can make better decisions, okay? For example, for this one, I got a print time of 1 hour and 44 minutes. And I can simulate and check how my 3D print is going to go. Okay, just so you know, I have an infill setting, a wavy infill setting, about 20% or something like that. There we go. So this is how my print is going to go. Okay, I can make the simulation run by itself. Right? Or I can just check on every single layer there for my manufacturing to check how this is going to go. For example, from experience, I also know that creating this hole right here, it's going to give me trouble, right? Because for some of those features right there, I might not have the required material to support this region right here, okay? So I don't need to send this to the 3D printer and mess it up and say, oh, shoot, okay, I messed it up. I need to make a change. With the simulation, I can tell those kind of things and make the necessary changes in case I need it. There we go. I have my support there. I can generate my toolpath again. That's sum up 37 seconds. No, that's not a lot. But now I'm going to make sure that my hole is going to be created and my part's not going to collapse there. Up a little bit. There we go. My supporting part. Right, so that's basically what I wanted to show today, how we can integrate the whole digital prototyping process inside of Fusion, okay? The main points that you need to take into consideration, that is, sending this to simulation, that is, simulating the forces, simulating the constraints that you need for the part, simulating how this is gonna be represented in real life. That's vital, right? And how you can make your validations with the latest tools that we get available in industry. That is 3D printing, that is advanced milling, 5-axis milling, anything you need. Everything's gonna be embedded inside of Fusion. So, and if you're familiar with the collaborative insights of Fusion, that makes sense, you can know that it's not like one single person needs to do this, okay? If everyone's part of the team, everyone has access to this project, you can tell Jimmy from FAM to make the simulation. You can tell Andrew from the detailer to make the drawing for this part. Send this to Andrea for manufacturing so she can create the model, 3D print it, and test it out.